All right, so 10.6, we are now dealing with special right triangles. So hopefully you've gotten those reference angles down because we are getting into the nitty-gritty of why they are so important. First though, bell work. We need to remember to convert radians to degrees and degrees to radians. So, remembering our conversion factors, since we have 9 pi over 4, I am going to multiply this by 180 divided by pi. This allows my pi's to cancel out. I'm going to take 9 times 180 and then divide by 4 and see that my degrees is 405 degrees. Number 2, we are converting from degrees to radians. So we're going to take our 300 and we're going to multiply it by pi over 180 since radians has pi on top. I do 300 divided by 180. I then press the math button and the frac button and enter, and we're going to see that it's going to be 5/3. But because that pi is on top, we're going to say 5 pi over 3. That is important. Remembering to evaluate stuff from last, hopefully, lesson that you paid attention to. We need to find and evaluate tangent 3 pi over 2 using our quadrantal angles or our unit circle. 3 pi over 2 is the exact same thing as pi over 2, 2 pi over 2, 3 pi over 2 as this angle right here. Remembering we are going down a -1, but we're still at x equals 0, so there's our x and our y value. Our radius is always 1, and now we need to remember what tangent means. Well, tangent is opposite over adjacent, but for this, it is the same thing as saying y over x. So we're going to see that our y is -1 and our x is 0, but -1 divided by 0 is undefined. Remembering our quadrantal angles. At negative pi over 2, we make our little angle quadrant, unit circle thingy, that one. And since it's negative pi over 2, it's actually just right here. So we are saying right here, ironically enough, the exact same place as 3 pi over 2, which means our point is 0, -1 of x over y. Our r is still always 1. Sine, again, is opposite over hypotenuse, but we don't know those. So we have to remember that opposite means y, and our hypotenuse is r. So our y is -1 and our r is 1. So -1 divided by 1 equals -1. So sine of negative pi over 2 is -1. Remembering our quadrantals, seriously, those are so important. It's going to help, I promise. Okay. So getting into the nitty-gritty, special right triangles, what we really need to understand throughout this lesson is how can I evaluate trig ratios with 30, 45, and 60 degree reference angles. So again, that whole thing about reference angles being important, here they are. So what we mean by 30, 45, and 60 is these are the only 2 triangles you're going to be creating in this section. When you get to trig, it gets harder. But right now we're looking at 30, 60, and 45. So the 2 triangles you're going to look at are 30, 60, 90, and 45, 45, 90. Those are the only 2 triangles you're going to be looking at. What you have to understand is even though we know the angles, and we need to remember the special side lengths that go with them. So these, obviously right now you're not going to be taking quizzes or tests, but I highly suggest you remember these if you are going further in mathematics. You need to remember these. So what this says is for our 60, 30, 90, we have 3 side lengths, and we know what those are. When I see 30, 60, 90, I have to remember 1, 2, 3. The reason why we remember 1, 2, 3 is because the side length that goes with the 60 and 90 is 1. Our hypotenuse is always 2. And our 30, 90, so I remember my 3 goes with my 3. But my 3 is the square root of 3. So a 30, 60, 90 triangle has side lengths 1, 2, square root of 3. You will have to know these, okay? Our next one, 45, 45, 90. So the nice thing is since this is a isosceles, that means two sides are the same. A 45, 45, 90 is 1, 1, 2. So the nice thing is between your 45 and your 90, you have side lengths 1. Your hypotenuse, though, is the square root of 2. So back in the day, mathematicians found out, well, our ratios of 60, 30, 90 and 45, 45, 90 at the bare minimum are these with the side lengths, no matter what. For any triangle that is 60, 30, 90, the ratio between here, here, and here is 1, 2, square root of 3. And the same is for 45, 49, 1, 1, square root of 2. The reason why we deal with square root of 2s is because 1 is very nice to deal with. And you're going to see why in just a moment. Unit circles and special right triangles. Super important. Please memorize these. Obviously, you'll have these for reference when you're doing your homework, but memorize these. Okay? So the steps for solving and evaluating these trig ratios with our lovely new side lengths is your first step is to draw the triangle. We are drawing the triangle. Determine which triangle it is. We then determine the reference angle, which I hope you're really good at after 10.5. We're determining the reference angle. You are then going to label the side lengths based off of what your reference angle is. And then you're going to write the ratio. Remembering that the ratio is y over x, y over x for tangent, y over r for sine, and x over r for cosine. Those are important. And you need to always remember, so when we do these, the radius is always positive. So our r is always positive. And you're going to see why we say positive in a moment, because our x's and y's can be negative. But our radius, no matter what, so the 2 and the square root of 2 are always positive. Always. Okay? All right. So now we're going to get right into the examples. We need to evaluate 150. So first things first is we need to remember how to make our terminal angle. Well, we're at 150, and remember reference angles is the thing that is closest to the terminal and the x-axis. So 150 is very close to 180, so we know we're going to be using this x-axis, but it is less than 180, so we are in this quadrant, and we're going to create our triangle, just like what we did last unit. So what we now need to find is our reference angle. Just like last unit, we're just going to add another step. Well, our reference angle is the difference between 180 and 150, which means it is 30 degrees. Okay, so if this is 30 degrees, then the other one has to be 60. So this is our 30, 60, 90 triangle. And now we have to remember our 1, 2, 3. Again, wherever the 3 is, that is also where the square root of 3 is. Our hypotenuse is our 2, and our 60 through 90 is 1. So our 1, 2, square root of 3. But here's the difference. What quadrant are we in? Well, we are in this lovely quadrant where our y's are positive, our radius is always positive, but our x's are negative. So you have to pay attention to negatives based off of the quadrant you are in, okay? Because remember, this is at 0, 0. So we do have negative aspects here. Now we need to remember sine. Well, you can start using your SOHCAHTOA here since you have created a triangle, but it's really helpful to get that y over r, x over r, and y over x down. But just as a reference, so sine is opposite over hypotenuse, which is the exact same thing as saying our y over our r. Well, let's prove that. Well, opposite is 1, which is our y value. I like labeling y, r, and x. And our r is our hypotenuse. So it's the same thing. So we say our y is 1 over our r of 2. So sine of 150 is 1/2. You can check this by putting it in your calculator, but if you have noticed throughout my lessons, if you watch them, I haven't been using it. There's a reason. Obviously, you can figure out 0.5 is 1/2. But what happens when you start dealing with the square roots? Can you figure those out? Not really. They won't be able to do math frac for you on that. So you have to create this scenario. Please do that. Don't put this in your calculator. This is straight. You create a picture. You show where your stuff's at. You write it down. Okay? Number 2, we have tangent of 225. Well, tangent of 225, remembering that this is 90, 180, and 270. Well, we know it has to be between 180 and 270, but we look at our x-axis of 180, so we have to be between our x and our terminal. Our terminal is our 225. We create our triangle, and we have to find our reference angle, just like last unit. What is the difference between 225 and 180? Well, it's 45. So our reference angle here is 45 degrees, meaning our other angle over here is 45 degrees. So remembering our side lengths now for a 45, 45, 90, it is 112. So that means between 90 and 45, we have 1, 1. But remember, the hypotenuse for this one is the square root of 2. So 1, 1, square root of 2. We have our x value, our y value, and our r. But we have to remember what quadrants we are in. We had to go negative x, and we had to go negative y. So those two were negative. But our r is always positive, so don't change that. And we need to remember our tangent. Tangent, again, is saying opposite over adjacent, which is the same thing as y over x. So we see our y is negative 1, and our x is negative 1. So negative 1 divided by negative 1, tangent of 225 equals 1. I know it's a lot of process just to get to an answer of 1, but this is so important. Please get this stuff down. Okay? All right, if you're feeling confident, go ahead and pause the video and attempt the rest on your own and then check with me. If not, please continue and follow along. We've got 6 more problems, making sure we understand. Okay. So now we're going to get into the radian aspects. Once again, it's that thought process. Am I closer to pi or 2 pi? All right? So am I closer to pi or 2 pi? Denominator is 4, so we're going to think of 4 pi over 4 or 8 pi over 4. What am I closer to with a 7? Our 8 pi over 4. So we know we're going to be over here looking at 8 pi over 4, just 2 pi. Since I am 7, that means I'm 1 away. Remember, going through our angles, we have to go all the way around, so we're in this quadrant. Means my terminal is in here, 7 pi over 4. I connect, creating my triangle, and now I need to find my reference angle. Well, remember reference angle, it's the difference between your terminal and your x-axis. So what's the difference between those? Well, it is pi over 4. So that's pi over 4. Do we have a triangle that has pi over 4 with a degree in it? No, so this is where conversions come back into play. So you're going to have to convert by multiplying by 180 over pi, taking 180 and divided by 4, and you're going to see that it is 45 degrees. Okay? So that means we have a 45, 45, 90 triangle. And remember, it's our 1, 1, square root of 2. So we have 1, 1. Our radius is the square root of 2. But look where your triangle is at. I am in the positive x's, but I'm in the negative y's. Okay, so you got to pay attention to where your negatives go. So there's our x, y, and our r. Cosine, remembering that it is adjacent over hypotenuse, or the same thing as our x over r. So x is 1, and our r is the square root of 2. Well, that's nice, but remember back in our rational days, do we like rationals in the denominator? We do not like rationals in the denominator. So to get rid of this rational, you're going to multiply by 1. But we are multiplying by 1 as the square root of 2 over the square root of 2. Remember, 1 can be anything as long as it's something over itself. So since we're multiplying by the square root of 2 over 2, 1 times the square root of 2 is the square root of 2. Square root of 2 times the square root of 2. If you remember back in the day, you can say the square root of 2 times 2, which is 4. Square root of 4 is 2. Or if you remember that if you're multiplying a rational times itself, it's the number underneath, so it's 2. So our answer here is the square root of 2 over 2. We do not like rationals. This is not correct. This is correct. This is not. So make sure you multiply by a rational, by the same rational over itself to get rid of it if it's in the denominator. Please do that. So important. Okay. So looking at cosine, negative 2 pi over 3. Once again, are we close to negative pi or negative 2 pi? Since we have a denominator of 3, we're going to look at negative 3 pi over 3 or negative 6 pi over 3. Well, 2 is really close to negative 3 pi over 3. So we know we are in this lovely area. And we're going to see that this is going to be negative 3 pi over 3. Since we are negative, we go this way instead of that way. So we're going this way. And it goes 2, 3, so we know we're in this area. So we know our terminal angle is in this area for negative 2 pi over 3. Our x-axis is already there, so we connect to create our 90-degree triangle. But now we need to find our reference angle. Our reference angle, again, is the difference between the x-axis and your terminal, or vice versa, but it's the positive. We are how many pi over 3s away from each other? We are 1. So our reference angle is pi over 3. Again, do we know a triangle that has a degree of pi over 3 for side lengths? No. So we need to convert. So you're going to convert, again, by taking 180 divided by pi and multiplying those. And you're going to see 180 divided by 3 is 60. So this is our 60-degree reference angle, meaning here is 60 and here is your 30. Since we have done that, we can now say 1, 2, square root of 3. This is our side lengths. Well, if this is our 30, my square root of 3 goes along with it. My 2 is my hypotenuse, and my 1 goes with my 60. Now we have to look for our negatives. We are in the negative x values, the negative y values, and our radius is always positive, so we don't have to worry about it. So now we've got to actually solve cosine of negative 2 pi over 3. Well, again, cosine is adjacent over hypotenuse, or the same thing as x over r. I'm just going to rewrite again because I forgot to put x, y, and r. Our x is negative 1 and our r is 2. So our answer is negative 1/2. No extra needed multiplication because there is nothing rational in the denominator. Okay? We starting to feel it? Starting to get it? Most important part of your last lesson, which is kind of cool. Means you're almost done. 4 more examples to go and we're going to be good. Our next one, tangent of negative 13 pi over 6. We're again in radians, so we must ask ourselves, are we closer to negative pi or negative 2 pi? So denominator of 6, are we closer to negative 6 pi over 6 or negative 12 pi over 6? I think 12 and 13 are really close to each other, so we're going to go negative 12 pi over 6, so we're looking at this lovely area here of negative 12 pi over 6. And we need to understand we are at negative 13. Well, we start here, we're going all the way around, we've hit 12, but now we need to get to 13 for our terminal angle, so we're in this area. So our terminal angle here for negative 13 pi over 6 is in this quadrant. We connect to create our right triangle, and we now need to find our reference angle. So what is the difference between negative 12 pi over 6 and 13 pi over 6, and it's positive? Well, they are only 1 pi over 6 away from each other. So we need to convert it because we need a degree for our triangles to use our special side lengths. And we're going to see pi over 6 is the exact same thing as 30 degrees. So our reference angle is 30 degrees. So we have a 30, 60, 90. Remember in our 1, 2 square root of 3, our 3 is on this side, so that means our square root of 3 is here, our 1 is here, and our hypotenuse is 2. Looking again where our triangle is created, we're in the positive x's, so that's good. But we're in the negative y's, so we are at -1 here. Remember, radius is always positive. Now we're in tangent, which is the same thing as opposite over adjacent or y over x. So once again, rewriting, because I keep forgetting to write x, y, and r. Our y is -1, but our x is the square root of 3. Oh, it's irrational. We don't like rationals in the denominator, so we must multiply by 1. Since this is the square root of 3, we're going to multiply by the square root of 3 over the square root of 3. We're going to see -1 times the square root of 3 is the negative square root of 3. Square root of 3 times the square root of 3 is 3. So, tangent of -13 pi over 6 equals the negative square root of 3 over 3. So important. Please make sure you're doing this. I don't know why I'm whispering. On 6, sine of 0. Oh, okay. Well, sine of 0 is right there. Right? Sine of 0 is right there. There's my x-axis. Do I have a terminal angle? Did I create a triangle? Okay, well, what's my point? Well, my point is I went x over 1, didn't go anything over y. Well, since I didn't create a triangle, that means my r is 1. That's nice. Okay, well, sine. Trying to remember all that jazz. Remember, sine is y over r. My y is 0. My r is 1. So 0 over 1 is 0. That one's nice. So remember, I can give these to you. Remember, your quadrantals are points, and your r is always 1. So it is different. Because we didn't create a triangle, there's no way we can use these reference side lengths. You'll have to use the xy point and your r of 1. Those can be given to you. All right, 2 more to go. And then just your homework. And then 2 reviews. And that's all you have to do for the rest of the year. How awesome is that? All right, so 7. We now have the tangent of 60. Well, that's interesting. 60. Is that less than 90? Therefore, we already know our reference angle. But we have to make sure we're in the correct quadrant. So, since it is less than 90, we know we are going to be dealing with this x-axis at 0. This is 90, so we know that right in here for our terminal is our 60 degree. We are going to connect, creating our right triangle, and since this is 60 degrees, our reference angle is also 60 degrees. So that means we have a 30, 60, 90, meaning we have a 1, 2 square root of 3 side lengths. So since this is where our 3 is, my square root of 3 is next to it, my 60 is 1, and my hypotenuse is 2. Okay? We are in this quadrant. It's positive everywhere, so our x is positive, our y is positive, and always our r is positive. So we do have tangent, though, and tangent is y over x. Well, our y is the square root of 3 over our x of 1. Well, that's nice, because the square root of 3 divided by 1 is the square root of 3. And it's not in our denominator, so all our answer is the square root of 3. Sounds nice. Starting to see it. Last one, almost done. So sine 7 pi over 6. Since we're in radians, once again, we need to ask ourselves, are we closer to pi or 2 pi? Since our denominator is 6, our choices are between 6 pi over 6 or 12 pi over 6. We are definitely closer to 6 with our 7, so we know we are right here with our 6 pi over 6. Since we do start this way and come this way, our 7 pi over 6 says our terminal angle is in this quadrant. We connect to create a right triangle, and I now need to find my reference angle. Again, reference angle is the difference between your x-axis and your terminal. We are 1 pi over 6 away, but we need a degree, so we're going to multiply, not equal, times 180 over pi, and we're going to see our reference angle is 30. So that means this is 30, and this is 60. Remembering our 30, 60, 90 triangles, it is 1, 2 square root of 3. If this is where my 3 is, then my square root of 3 is next to it. My hypotenuse is 2, and our 1 is next to 60. Looking at our quadrant though, there's going to be a few negatives. We are in the negative x area, the negative y quadrant, and then our radius is the same. So we have created our triangle, and now we need to solve for sine 7 pi over 6. Well, since we are in sine, it is the same thing as saying y over r. Our y is -1, and our r is 2. No rationals were needed, so our answer is -1/2. Okay. I highly suggest that you take this week stuff very seriously. It is super important if you go into trigonometry to have this down. It makes the first kind of couple of weeks really easy for you. All right, this is the last lesson of Unit 10. Your review is the week after, and your final review is with that. That's it. Have a good rest of your summer.